Hi. Um, Now I'm going to be explaining both, so two objects moving together. In this scenario, we're going to have them both moving in a negative direction, so that's from the right side of the screen over here to the left over here. And what's going to happen is one of the objects is going to start off, and it's going to be slower than the other one, but it will get a head start. And then the other one will be let go. It's going to be faster and it will pass the slower one that started off first. So let me show you that video. So there it starts off, and then there the faster one passes it up. So through this video we put it into Tracker. Through Tracker we get data points, and with those data points we input them into Logger Pro and we get this graph right here. So here we have the slower object being represented by this red line, and the faster object being represented by this black line, or cluster of dots. So the position is the same. I mean, not the position. The equation is the same as most others. It's position equals slope times time plus the y-intercept. So let's start off with the slower object. So the slower object, its slope is equal to roughly -7 inches a second. So every second it would move 7 inches in the negative direction, and its y-intercept is roughly 3 inches. So its starting point was 3 inches. And here we have the um, faster of the objects. Its slope would be roughly -9 inches a second. So every second it would move 9 inches in the negative direction, and that is clearly faster than the slower one. That's why it is the faster one. And its y-intercept, its starting point, is roughly 10 inches. They should be the same, but who cares? Little mistakes. So, since the slower object was allowed to move first, its line is a little more straight. It is straight. But the faster object, since it was being held still for a while, it has this little plateau up here, and then once it lets go is right around here. Then it goes. It's steeper because the slope is its slope is big. But now that I realize it, that is not the actual slope of the faster object. If I wanted to find the slope of the faster object, I would have to do this. I would have to hold up. I would have to take these points here where it's steady, and then I would have to strike through those data cells, and then here, that is the correct slope of the faster object, because it is not counting those points where it's held still. So this is the actual speed of the faster object, which would be roughly -15 inches a second. So every second it would move 15 inches in the negative direction. Clearly more faster than the slower one. It's nearly double. And the y-intercept for this one is roughly 28 inches. But if we wanted to find the right y-intercept, we would use the one previously. And I would undo, and that 10 inches is the correct y-intercept. So that is the correct starting point. But that is not the correct slope. So for the correct slope, we would do the strike through, and we have to find the slope of just the curve, these straight lines here, not these. Yeah.